Hello everyone, and in today's lesson we shall be looking at this particular example on the board, and this is going to be our last example that we are going to look at under the Quasilinear PDE. How we can use the method of characteristics equation to solve a Quasilinear PDE. If you haven't subscribed to the channel, kindly hit on the subscribe button for me. If you really want to enjoy the lesson, kindly stick and stay with me as we go through this particular question on the board. So we want to find the general solution to the PDE ux plus ux minus yuy is equal to x squared plus y squared with the auxiliary condition given ux to s is equal to what? 0. So looking at this PDE, realize that we have a dependent variable multiply its partial derivative with respect to x. If you are to expand the bracket, the same thing, we have a dependent variable u multiply its partial derivative with respect to y if you are to expand the bracket. So this PDE is a classical example of a quasi-linear PDE. You want to look at it and want to make use of all the characteristics equation. Remember, we are going to follow the same approach that we used when we were looking at the earlier examples we did in our previous lesson. So first, we are going to identify our A, our B, and then our F from the equation given. So from the equation given, our A is the coefficient of what? Ux. So this is our coefficient. We have A is equal to what? Ux plus what? Y. And then our B is the coefficient of what? Uy. And that is the whole of this. So we have U multiplying X minus Y. And then we move on to our F. So our F is what? The function on the right hand side of the equal sign. So we have s squared plus what? Y squared. So once we have this, we write down the characteristics equation. So we know that the characteristics equation is given as what? Dx all over A is equal to what? Dy all over B, and this is also equal to du all over F. Now once we write down the characteristics equation, we are going to plug in this. So we have our dx all over A, this is our A, and then we have our dy all over B, this is our B, and then we have our du all over F. So we can see that the characteristics equation has transformed this PDE into an ordinary differential equation, and once you have it, you can make use of any method that is used to solve a ordinary differential equation to solve this particular equation. Since our f is not equal to 0, it means we are going to form two solutions. We are going to form two equations, and these two equations is going to give us two solutions. So we have our first equation. So with our first equation, we are going to pair the x and then the y, and then we solve for our first solution. So we are going to do what? Pair our dx and then dy. So we have dx all over what? U x plus y, and then we have our dy all over what? U x minus what? Y. Now once we read this point, let's clear the u from both sides of the equation by multiplying both sides of the equation by u, so that this u and u will go away. So we are going to have u multiplying dx all over what? U x plus y, and then we have u multiplying dy all over what? U x minus y. So from here you can see that this u will cancel this u, and then this u also cancel this u. So we are left with what? Dx all over x plus y is equal to what? Dy all over x minus y. So at this point, we realize that it will not be easy for us to separate the variables. It will not be easy for us to separate the variables. In that case, then we have to adopt another method or technique that will help us to find the solution to this PDE. Now let's multiply this by that, and then let's multiply this by that. So we are going to have dx multiplying this, and then dy multiplying this. So we are going to have x minus y multiplying dx, and this is equal to what? X plus y multiplying what? Dy. Let's bring all of them to the right hand side so that we can equate them to 0. So we are going to have x plus y dy, then we have minus x minus y dx, and all of it is equal to 0. Very, very easy and then simple. Let's rearrange them well. Let's bring this one first. So we have minus x minus y dx, and then we have plus x plus y dy is equal to 0. Now look at this differential equation very well. I believe you've come across it somewhere else. If you could remember, when we were looking at the ordinary differential equation, we came across a differential equation of this very form. So we said that, or we learned that when you have a differential equation which is of the form m sy dx plus n at x and then y dy is equal to 0, then del m, if del m del y is equal to del n del x, then the equation is said to be what? An exact. This is what we look at when we're looking at ordinary differential equation. So we said that if you have a differential equation of this very form, if del m del y is equal to del n del x, then the equation is said to be what? Exact. So looking at this order differential equation, realize that it is of this very form. So we are going to check if it is exact. If it is exact, then we are going to base on exactness to find the solutions to the differential equation. From the equation, this is our m. So we have our m is equal to, we are going to get minus x plus y, and this is going to be what? Our n. So this is our n, the coefficient of what? Dy, and that is what? X plus y. Now after that, we find del m del y to see if it is equal to del n del x. If it is equal, then we can say that this differential equation is what? Exact. So we are going to have del m del what? Del y. We are differentiating this with respect to y. So when we are differentiating minus x with respect to y, it becomes a constant. So this will give us 0. And then when we differentiate y with respect to y, we get what? 1. Then we move on to del n del x. Del n del x. We are differentiating this function with respect to x. When we differentiate x with respect to x, we get what? 1. And then when we differentiate y with respect to x, we get what? 0, because y becomes a constant. So from here, we can see that del m del y is equal to what? Del n del x. So we can say that the equation is what? Exact. If it is exact, then we are going to base on its exactness to find the solution to this differential equation. Now we can all see that the equation is exact. Since the equation is exact, we can therefore see that del u del x is equal to what? M. And we know that m is equal to what? This. So we have minus x plus what? Y, which is the same as this one. And then we can also see that del u del y is equal to n. And we know that n is equal to what? X plus what? Y. So from here, let's start with this one first. We have del u del x is equal to minus x plus y. can say that del u is equal to what? Minus x plus y del s. We just cross multiply. So from here, when we integrate both sides, we are going to have our u is equal to, we are integrating what is in the bracket here with respect to x. When we integrate x with respect to s, we get what? S squared all over 2, and then plus, we are integrating y with respect to y. That gives us what? Xy plus a function of, we are integrating with respect to s, so any function of y becomes what? A constant. Very, very easy. So this is the first equation. Let's see first equation. And then we come for, let's say this first equation, then this second. Let's come for this. We have del u del y is equal to what? X plus y. So from here we can say that del u is equal to what? X plus y multiplying what? Del y. So let's integrate both sides. If we integrate both sides, we are going to get u is equal to, we are integrating this with respect to y. So we are going to have xy plus what? Y squared all over 2 plus a constant. Any function of x becomes what? A constant. So we have this. Let's continue from where? Let's continue from here. So let's call this equation 2. Now comparing equation 1 and 2, we can see that our f at x, a function of f at x only, is what? Minus s squared over 2. And then a function at y only, a function of y only, we have what? Y squared all over 2. So we can say that our solution, which is u at x comma y, is equal to what? Minus s squared over 2 plus y squared all over 2 plus xy. Since we have xy and then xy, we will pick one of the xy. So we know that when the differential equation, which is this one, is equal to 0, we can say that our general solution is equal to what? A constant. So it means that this is going to be the same as that. We have our constant is equal to what? Minus s squared all over 2 plus y squared all over 2 plus what? Xy. So this becomes our first solution. That is our C1. This is our first solution. Then we are going to look at what? Our second equation. So we are looking at our second equation. That is going to give us our second solution. So what we are going to do to the characteristics equation is that we are going to multiply each fraction by 1. So with this, we are going to multiply the top and down by x, top and down by y, and then top and down by what? U. So we are going to have x multiplying the x all over x multiplying u, x plus what? Y. And then we are going to have y dy multiplying what? Y. And then we have u multiplying u, and then what? X squared plus y squared. So from here, we are going to get x dx all over, let's bring u out so that we are going to get s squared plus what? Yx. And then here we are also going to get y dy all over what? Let's bring u out so that we are going to get what? Xy minus what? Y squared. And then this we are also going to get u du all over what? U and then s squared plus what? Y squared. So from this, all what you want to do is I want to make sure that the denominators are the same, and then we can equate their numerators and then integrate. That is what we want to do. And that's the main reason why we are going through this process. So we are going to apply another concept that we are very familiar with. He said that when you have two fractions, let's say 3 over 6 and then 1 over 2, and then these two fractions are equal, then we can either add or subtract their numerators, and then either subtract or add their what denominators, and this is equal to any one of the fraction 3/6, and that is equal to what 1/2. Let's check it out. 3 minus 1 will give us 2, and this will also give us 4. Then we have 1/3/6, and then 1/2. When you break that down, we have 1/2, 1/2, 1/2. So we are going to apply this concept to that. So from here, we are going to have x dx, then we have minus y dy, and then all of this is over what? U x squared plus xy, then we have minus u xy minus what? Y squared, and all of this is equal to what? U du all over what? U x squared plus what? Y squared. Since we have u and u, let's factor u out. So we have our x dx minus y dy all over. Factorizing u out, we are left with x squared plus xy. Let's expand the brackets. We are going to have minus xy plus what? Y squared. And this is equal to u du all over u x squared plus y squared. So from here, we can see that some of the terms can cancel themselves. This will cancel this. So at the end, we are left with, let's continue from here. We are left with x dx minus y dy is equal to u du. This is over what? U, and then we have x squared plus what? Y squared. X squared plus y squared, and then this is also over u x squared plus what? Y squared. So from this, we can see that the denominators are the same, and if the denominators are the same, we can just simply equate their numerators and then what? Integrate. So we can say that our x dx minus y dy is equal to u du. So from this, we can see that we have separated them into the x, y, and then what? U. So we can integrate. So this is going to give us, let me do it like this. This is going to give us x squared all over 2 minus y squared all over 2. Then we add our constant of integration. Since this one is c1, let's call this c2. And this is also giving us what? U squared all over 2. So let's make c2 the subject. So we are going to have our c2 is equal to what? U squared all over 2. This is going to give us plus y squared all over 2. And then we have minus x squared all over 2. Let's clear the fraction from it by multiplying through by 2. So we are going to have 2c2 is equal to u squared plus y squared minus what? X squared. A constant times a constant will still give us a constant. So we can call this to be what? c2 is equal to u squared plus y squared minus what? X squared. So we have our second solution. So this is our second solution. Very, very easy and then simple. And whenever you have two solutions, we merge them, we put them into a single solution. So it is either C1 becomes a function of C2, or C2 becomes a function of C1. So what do? We are going to make what? C2 to become a function of C1, since we have the dependent variable u in C2. So we can say that C2 is what? A function of what? C1. So we have our C2 to be what? Plus y squared minus what? X squared is equal to a function of C1. So this is C1. So let's clear the fractions away from it, so that we are going to have what? We are going to have 2c1 is equal to what? Minus x squared plus y squared plus 2xy. A constant times a constant will still give us a constant, so we can write it as c1 is equal to x squared plus y squared plus 2xy. So this is what we are going to use for C1. So we are going to have minus x squared plus y squared plus 2xy. So from here, let's make u the subject. So we have our u squared is equal to a function of minus x squared plus y squared, and then we have plus 2xy. Then we send this to the right hand side. We have x squared, and then we have minus what? Y squared. So we can decide to take the square root on either side of the equal sign, or we can decide to leave it in this well form. Let's leave it in this well form. So this becomes our general solution. So we have our general solution. Now realize that we're being given an initial condition, so we have to proceed to find the particular solution. So with the initial condition given, we said that our u at x, 2x is equal to 0. So this means that wherever we see x in the general solution, we should plug in what? X. And wherever we see y in the general solution, we should plug in what? 2x. And wherever we see u in the general solution, we plug in what? 0. Very, very easy. So we have u is what? 0. So we have 0 is equal to a function at our x is still x. So we have minus x squared. Our y is what? 2x. So we have 4x squared plus we have 2. Our x is still x. Our y is what? 2x. And then we have plus x squared. And this is also giving us what? Minus 2x power 2. So let's do some small simplification. This is giving us minus x squared plus 4x squared plus 4x squared. And then we have plus x squared minus 4x squared. So we have our 0 is equal to a function of, this is giving us what? 7x squared. And then we have what? Minus 3x squared. So we can bring the minus 3x squared to the left hand side, so that we are going to have f at 7x squared is equal to what? 3x squared. Very, very interesting. So what we are going to do is that we are just going to find out what happened to 7x squared that gives us this. So we are going to let any variable at all, let's say p. So we let p be equal to what is in the function 7x squared. From here we can decide to make x squared the subject, since we are having x squared here. And that's going to give us what? P all over 7. So this means that wherever we see 7x squared in this equation, we are going to plug in p, and wherever we see x squared, we plug in p over 7 in this equation. So we have f of p is equal to what? 3 is there already, but our x squared is equal to p over 7. So we have p all over 7. So at this point, what we are going to do is that we are going to go back to the general solution. So this is the general solution. And then wherever we see p, we are going to plug in this f at this function. Wherever we see p, f at p, we are going to write the whole of that. So we have f at minus x squared plus y squared plus 2xy is equal to 3 is there already. And then we have p, our p is the whole of this. So we have x minus x squared plus y squared plus 2xy all over what? 7. So this means that this is equal to that. So we are going to look through the general solution. Wherever we see this, we are going to plug in that. So we have our general solution. We have u squared is equal to, we are saying that the whole of this, which is the same as this, is equal to this. So we have 3 minus x plus y squared plus 2xy all over 7. And then we have plus x. squared minus y squared. So from this, let's expand the bracket and see. So we have our u squared is equal to minus 3x squared, squared here, and then we have plus 3y squared. This is giving us 6xy all over 7. Then we have plus x squared minus what? Y squared. This is over 1. Now we can do some small algebra by finding the LCM of that. This into that we have minus 3x squared plus 3y squared plus 6xy, and then we have plus this into that we have 7x squared minus what? 7y squared. So from this, we have our u squared is equal to, we can decide to bring 1 over 7 out, so that we will be left with what? Minus 3x squared plus 3y squared plus 6xy plus 7x squared minus 7y squared. So let's see if we can do some small cancellation. So we have finally our u squared is equal to 1 over 7. So we'll see if we can. So from here you can see that some of them can cancel. So we have 3x squared. This is going to give us 4x squared. And then we also have this is going to give us minus 4y squared. And then lastly we have plus 6xy. Very, very easy and then simple. So this becomes the particular solution of the question that was given. Very, very lengthy question. This brings us to the end of today's lesson. See you tomorrow. Bye bye.